Welcome. I am excited to present our project titled Machine Learning Based Regression Framework to Predict Health Insurance Premiums. This work was carried out by me, Ashwini, and my teammate Sukanya under the guidance of Professor J.B. Simha. In this video, I'll walk you through our end-to-end machine learning implementation that predicts insurance premiums based on personal and demographic attributes. We have taken an existing a research paper on our basis and added several improvements using the state of the art tools like SHAP, Ensemble, learning and deep learning. So we'll see what this project about. Health insurance premiums is highly variable and depend on the numerous factors like age, smoking habit and even geography. The original 2022 IJERPH paper tackled this using the machine learning regressor such as linear regression and XGBoost. We decided to replace and extend this study in three major ways: hyperparameter tuning for better accuracy, a more robust ensemble model including the CatBoost, SHAP for explainability. These changes made our teamwork both more accurate and interpretable, which is crucial for real world adoption in insurance. We use a well-known dataset from Congo. It includes over 1,300 records and 7 columns: age, BMI, number of children, sex, smoking status, region, charges. Pre-processing involved one hot encoding of categorical columns, standardizing numeric values. Importantly, the dataset has no missing values, which made the pre-processing straightforward. This step was essential to ensure that the model would not be biased due to the scale or categorical misinterpretations. First, we implemented the baseline models from the original study, linear regression as a benchmark, decision tree which handles non-linearity, random forest, a strong ensemble method, XGBoost known for high performance in tabular data. These were evaluated using RMSE and R square. Interestingly, XGBoost outperformed the others in the base setup, which aligns with what we usually see in structured data scenarios. Next comes extension 1. Tuning the methods to get the better performance, we use the randomized search CV, which randomly samples a set of hyperparameter instead of exhaustively searching everything. This is faster and often just as effective. For example, in random forest, we tune parameters like n estimators, which is number of trees, maximum depth, minimum sample split. For XGBoost, we optimized learning rate, gamma, subsample. The results showed noticeable improvements in RMSE and R square compared to the default values. Then we built an ensemble model using the voting regressor. This is extension 2. It combines the predictions from tuned random forest, tuned XGBoost, CatBoost regressor. CatBoost handles categorical data natively and performs well in small to medium datasets. This ensemble leverages the strength of all three, reducing variance and overfitting. As expected, it yielded more stable and generalizable predictions.
Hello everyone, I am Sukanya. Today I will be presenting the second half of our midterm project, which is based on the paper titled Machine Learning Based Regression Framework to Predict Health Insurance Premiums. My teammate has already explained the problem and methodology. Now I will walk you through the extensions we made, the model performance, insights and our conclusion. Extension 3. SHAP Explainability. We introduced a third extension using SHAP, Shapely Additive Explanations, to improve model explainability. SHAP helps us understand why the model is predicting a certain insurance premium for each individual. We used SHAP values to interpret model outputs. The top influences were smoking status, which had the highest impact, followed by BMI and then age. We also generated SHAP summary plots and depends plots, which usually show how these factors affect premium predictions. This makes the model more transparent, especially important in fields like healthcare and insurance where explainability matters. Visual insights. To better understand the data, we explored visual insights. We used histograms, pair plots, and regression plots. Some key observations were charges increased significantly with age and BMI. Smokers were consistently charged more, which aligns the real world insurance pricing logic. These visuals helped us see clear linear and non-linear trends in the dataset. Performance comparison. Next, we compared the performance of two models, linear regression and an artificial neural network, ANN. Here is what we found. Linear regression had an R-square score of 75.09% with high RMSE and low accuracy. In contrast, ANN achieved an R-square score of 92.72% with low RMSE and high accuracy. This shows that the ANN model is much better at capturing complex relationships in the data compared to linear models. Correlation matrix. We also looked into the correlation matrix to see how different features related to each other. Positive correlations were observed between smoking and charges and also between age and charges. Negative correlations were noted with region, especially people from the southwest and northwest paying lower premiums. These correlations were visualized using a heat map, helping us confirm which features are statistically significant in predicting insurance premiums. Conclusion. To conclude, we achieved enhanced prediction performance using ANN and feature engineering. Model transparency was improved through SHAP explainability. The high accuracy of our model shows strong real-world applicability in the insurance industry. Our work not only reproduces the original paper but goes beyond by adding explainability and improving predictive power. This concludes our presentation. Thank you for listening.